Okay, so here unit 4, flip-flops and applications. Flip-flops and its applications. So basically, starting with this chapter, whatever we have studied until in like binary adders, subtractors, multiplexers, encoders, decoders, or all those type of networks are combinational networks. Okay, so whatever we have studied up till previous classes, all are combinational networks. Now here, basically, what are the combination networks? Combinational network, in combinational network, the output depends only on the present inputs at that instant. So because as the combinational network depends only on the present inputs, okay, the output of the combinational network depends on the inputs applied at that instant of time. Okay, so here we are going to study what is a combinational network. Combinational network. Okay, so combinational network is a network in which the output depends on present inputs on present inputs at that instant. So here what happens, the output depends on the present input only, so past history of inputs are not required for the output, so there is no necessary of memory. So combinational network does not have memory. Combinational network does not have memory. Okay, so this is one type of network, that is combinational network. Next, second type we have sequential networks. Sequential networks. So now in sequential network, the output depends on present and past history of input. On present and past history of inputs. So in order to preserve this past history of input, we require memory. And we also have feedback in sequential network. Okay, so here a sequential network can be defined as a two-valued network in which the output at any instance are dependent not only on the present inputs at that instant but also upon the past history or the past sequence of the inputs. Okay, now we need to preserve this past history of the inputs. So how to preserve this past history of the inputs? For this reason only, sequential networks are said to have memory. Okay, the mechanism which is used to explain this type of network is nothing but it is referred to as internal state, secondary state, or simply the state of the network. Internal state is nothing but it is a collection of signals at a set of points within the network. Okay, a state may be a logic 0 state. Okay, a logic 0 state, or a state may be logic 1 state. So in the 0 or 1 state, logic 0 or logic 1 state. So a sequential network can have, it can be in the state of logic 0 or it can be in the state of logic 1. So we call it as a state. How do you define a state? It is a state of the sequential network. Maybe in the state of logic, means it is preserving a 0 logic, that is logic 0 state. If it is preserving a 1 state, logic 1 into its network, then it is a logic 1 state. Okay. So here we have the basic two types of sequential network. One is synchronous network. Okay. One more is asynchronous networks. Okay. A synchronous sequential network is one in which its behavior is determined by the value of the signals at only discrete instants of time. Okay. And the second type of sequential network is known as asynchronous sequential network. Okay. So here basically we have memory in the sequential network. Okay. So let me talk about the flip-flop. What is a flip-flop? Flip-flop is a bistable logic element which has memory. What is a flip-flop? Flip-flop is a bistable element in which we have two logic states, logic 0 and logic 1. In order to preserve the states or in order to preserve the inputs or outputs, we should have memory. So flip-flops have memory to store the states. State may be in the networks may be in the either logic 0 or logic 1. Okay, that is referred to as state. If the network is having a logic 0 inside its network, then it is logic 0 state. If the network is having storing logic 1, then it is known as logic 1 state. Okay. So next here, the basic bistable element. What do you mean by bistable, students? Bistable is having two stable states. Bistable means it is having two stable states. So let me draw the basic bistable element. It is nothing but two inverters connected back to back. So how do I draw this? Having two inverters connected in this way here and this one connected here. Okay. So here the inverters are connected back to back. So here I would like to draw with a little space again in order to explain it. Okay. So here we have a inverter connecting and here we have a inverter connecting. So the output of the first inverter, this is the first inverter, this is the second inverter. The output of the first inverter is connected as a input to the second inverter and the output of the second inverter is connected as a input to the first inverter. Okay, so let me label this now. Input of the first inverter is X. Okay, next output of the first inverter will be X bar. Okay, so this output is known as Q. Okay, and this output is known as Q bar. Okay, Q and Q bar are complement to each other. Okay, so input of the second inverter is Y. Output of the second inverter is Y bar. Okay, so here you can see the inverters are connected back to back. It is known as a basic bistable element. Actually, this is the principle used in all the flip-flops. Basic bistable element has two stable states. Okay, let me assume now.
Excuse me, ma'am.
Yes, tell me.
Ma'am, how is the input for the
So here okay, so here when I talk about x is 0, okay, so listen properly all of you. X is 0, so what happens? X bar will be 1. So immediately Q also will be 1 and Y also will be 1, isn't it? So if Y is 1 means Y bar is 0. So Q bar will be 0. So you can see here now Q and Q bar are complement to each other. Q is equal to 1, Q bar is equal to 0. So this basic bistable is storing logic 1 at Q and logic 0 at Q bar. So this is stable state. This is a stable state. Okay. So now I assume again x as 1 comma x bar will be 0. So Q will be 0. Here y will be 0. Y bar will be 1. Okay, y bar will be 1 comma Q bar will be 1. This is known as another stable state. This is known as other stable state. Okay. So this is the first stable state and this is the second stable state. Totally it is having two stable states. Totally it is having two stable states. If Q is 1, if Q is 1, it is known as logic 1 stable state. If Q is 0, it is a storing 0, no? So it is logic 0 stable state. So here you can see that Q and Q bar are complement to each other. If Q is 1, Q bar will be 0. If Q is 0, Q bar will be 1. Okay. So if it is Q is 1, no, it is known as logic 1 stable state. Okay. If Q is 1, Q bar will be 0. Or if Q is 0, Q bar will be 1. So these are the two stable state preserved in this basic bistable element. If Q is 1, it is logic 1 stable state and Q bar will be 0. If Q is 0, it is logic 0 stable state. Okay. In this way, it can store two stable states. In this way, it can store two stable state and hence the name basic bistable element. Bistable means it can preserve two stable states. The binary symbol that is stored in this basic bistable element is referred to as content of the state or content or the state of the element. Q 1 idre idr content 1 irutte, Q 0 idre idr content 0 irutte and content is also known as a state of this element. State of this element. If Q is 1, state 1, it is state preserving 1 logic 1. If Q is 0, it is preserving logic 0. Okay. The state of the basic bistable element is given by the signal value at the Q output terminal and hence the Q output terminal is called the normal output, whereas the Q bar output is referred to as complementary output. Okay. When this device is storing a 1, it is said to be in its 1 state or set state. Q is having 1, it is known as 1 state or it is also known as set state. On the other hand, when the device is having storing a 0, it is said to be in 0 state. When the device is having 0, it is said to be in set state or reset state. Okay. So although this basic bistable element will be in one of its two stable conditions. Okay. ಅದರಲ್ಲಿ 1 ಇರುತ್ತೆ ಅಥವಾ 0 ಇರುತ್ತೆ. So ಈ ತರ ನಾವು ಏನು what we studied here is two stable states. One normal output when Q is 1 and one when Q is 0 it is complementary output. Okay. There one more state exists, that is one more equilibrium condition exists. That equilibrium condition occurs when the two output signals Q and Q bar are about halfway between associated with logic 0 and logic 1. Thus, the output is not a valid logic 1 when it is not valid logic when Q and Q bar halfway between reaching the logic states, maybe 0 or 1, and that condition is not a valid logic signal, and that is known as a metastable state. Okay, metastable state is unpredictable, it has to be eliminated. Okay, so what is the third state? Metastable state. When Q and Q bar are halfway between reaching the logic levels, maybe 1 and 0, that is known as metastable state. A small change in any of the inputs signals may quickly cause the basic bistable element to leave the beta stable state and enter into one of its stable states. Okay, any noise or any change in the input signals may cause the Q and Q bar output to move away from the metastable state to stable state. Okay, next, coming to this flip-flop. What is a flip-flop? Flip-flop is a basic bistable device with inputs that remain in the given state as long as the power is applied and until input signals are applied to cause its output to change. Okay, a flip-flop, it consists of a basic bistable element in which appropriate logic is added in order to control its state. The process of storing a 1 into flip-flop is called setting or presetting of the flip-flop, while the process of storing a 0 into flip-flop is called resetting or clearing the flip-flop. Okay, so we have here two sets, that is the logic 1 and logic 0. The process of storing a 1 into a flip-flop is known as setting the flip-flop, and the process of storing 0 into the flip-flop is known as resetting or clearing the flip-flop. So here the set state is nothing but preserving a logic 1 into the flip-flop is set state. Preserving logic 0 into the flip-flop is a reset state. So it depends again on the Q value. Q depends on the present input as well as the past inputs. Okay. So Q is having 1 means it is in the set state. Q is having 0 means it is in the reset state. And one more thing here is Q and Q bar are complement to each other. So here what are latches? They belong to some one form of,
Excuse me, ma'am.
yes,
Ma'am, is there any difference between logic one stable?
okay. So here next one I am going to teach latches. The latches are the devices, okay, they form one class of flip-flop. But the difference between the flip-flop and a latch, this class is the latches are characterized by the fact that the timing of the output changes is not controlled. The output changes is not controlled in latches, whereas in flip-flop there are again two types, edge triggered flip-flop and pulse triggered flip-flop. The output changes according to some enable signal, according to control signal, some control signal or some enable signal. Okay. So this is a difference between the latches and the flip-flop. Latches, the output changes is not controlled. Flip-flop, the output changes according to some control signal or according to some enable signal. There is a control over the output changes. Or if you do something modifications at the output side, it obviously depends on some control signals at the input side. Okay, so latches and flip-flop, this is the difference between the latches and flip-flops. So a flip-flop is a basic bistable device. It is a circuit having two stable state. The preserving logic 0 state into the network is known as reset state. Preserving one state into the flip-flop is known as set states. There are three classes of flip-flops. One is latches. The latches, in the latches, the output respond immediately when enabled. That means whenever the input changes, at the same instant of time output changes. No timing control. Okay, next we have pulse triggered flip-flops. Output responds to the triggering pulse. Okay, edge triggered flip-flop, output responds only to the control edge. Okay, so here we have some edges, positive going edge or negative going edge, that it will respond. That is edge triggered flip-flop, the output responses to the control input edge. Okay, the conventions, the circuit is set means the output is 1. The circuit is reset means the output is 0. Flip-flops have two outputs, Q and Q bar, or Q and Q bar we can write like this also, or you can just have a tick over here. Okay, so flip-flop has two outputs, Q and Q bar, which are complement to each other. Q and Q bar are complement to each other. Okay, due to time related characteristics of the flip-flop, Q and Q bar are usually represented as follows. The Q represents present state, Q plus represent next state. So there are four types of flip-flop: SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. So these type of flip-flops we are going to study. So SR latch. Okay, SR. S stands for set, R stands for reset. SR latch consists of S input, that is set input, which sets the circuit. R input, that is reset input, which resets the circuit. Q and Q bar output, that is output of the SR latch in normal and in complement form. The Q is said to be normal output, Q bar is said to be the complement output. Okay, so example of this is switch debouncer. We'll be studying this later. So now SR latch. What do you mean by this SR latch? Set reset latch. You can see here the SR latch, isn't it? How it is connected? How it is connected? R and S. Two NOR gates are connected. Okay. So NOR gate can also be written as like this, or not, isn't it? So consider this now. R input is given to this OR gate in the top. S input is given to this, the lower OR gate. The output of this first OR gate is connected to this NOT gate. The output of this NOT gate is connected back to the input, one of the input of the lower OR gate. Next, the output of the lower OR gate is connected as an input to this NOT gate. The output of this NOT gate is connected as an input, one of the input to this OR gate. Okay, the upper output is nothing but Q. The lower output is Q bar. Q is its normal output, Q bar is complement output. So this is the logic symbol of the SR latch. Okay, this is a logic network. This is the logic network and this is a symbol SR, Q and Q bar with a box indicating two lines, two inputs, two outputs. SR input, Q bar output. Here you can also write like Q bar, you can write like this, Q also with the bubble at the output side. This is also another way of representing the symbol of SR latch. Okay. Let me consider now here First, this is a truth table defining inputs S and R, outputs defining Q plus bar. Q plus is nothing but indicates next state. Okay, this is Q plus bar complement of the next state. Let me put these values and let me know what I will get. Okay, S is 0, R is 0 here. S is 0, R is 0. Let me assume that Q is 0 and Q bar is 1. Q bar are always complement to each other. So Q is 0, Q bar is 1. So this Q bar in turn, that is the output of the second NOT gate, this Q bar is connected back to the input of the first OR gate. So what is this value? It is 1. So 1 will come here, isn't it? So 0 or 1, what I will get? 0 or 1, what I will get? 1 I will get. This 1 acts as an input to this NOT gate. So what I will get here? Output of this NOT gate, I'll get 0. This in turn, this 0 is connected back to the input of this. Okay, this 0 will come for the input, one of the input of the NOR gate. 0 or 0, what I will get here? 0. 0 is acts as an input to this lower NOT gate. What is the output of this? 1. So this 1 will be nothing but Q bar. Okay, 1 is equal to Q bar or Q bar is equal to 1. So what did I get, students? When applying R and 0, R is 0, S is 0. Previously I assumed that Q is 0 and Q bar is 1. When I applied S0, R0, I am getting again Q as 0 and Q bar as 1. Same I am getting, isn't it? Whatever I assumed previously, when I apply S and 0, R as 0, I am getting the same outputs. Q0 and Q bar 1. So it is retaining the same states, earlier state. So it is written Q and Q bar. Why it is written Q and Q bar? Because it is retaining the earlier states, whatever it was there. Okay, it is retaining the earlier states. Any doubts in this? Yes? Any doubts in this? Ask me please. First row I have explained. First row I have explained. S is 0, R is 0. Here, that time what happens? I am assuming Q is 0, Q bar is 1. Okay? If suppose Q is 0, no? I am assuming this Q is 0, Q bar is 1. Q is 0. So this 0 comes here. 0 or 0, 0. 0 is given as an input to this NOT gate. 1 will come here. This 1 is given as an input to this OR gate. 0 or 1, 1 I will get. Next, this 1 is applied as an input to this NOT gate. 0 I will get. Isn't it? So, whatever I had assumed the previous outputs Q and Q bar, that only I am getting. Isn't it? So, it is Q and Q bar. Next. So, next again I will be going with second row. First row I have explained, second row. Okay, S is 0, R is 1. S is 0, R is 1. Assuming Q is 0, Q bar is 1. Okay, so this 0 will come here. 0 bar, 0 I will get here. Okay. 0 or 1 I am getting 1 here. So Q bar will be 1. 1 is applied here again. 1 or 1 I will get 1. Here I am getting 0. So again I will get 0. So here Q is 0. Q bar is 1. You can see Q is 0. Q bar is 1. It is said to be in reset state. Q is 0 means it is in the reset state. When I apply S is 0, R is 1. Third row is S is 1 and R is 0. S is 1, R is 0. Okay, assuming Q is 0, Q bar is 1. S is third row. I am talking about the third row. S is 1, R is 0. I have applied here S is 1, R is 0. I am assuming Q is 0, Q bar is 1. So this 0, no? This 0 will come here. Okay. So 0 or 1, I will get 1 here. This I will get 0 here. So I will get 0 here. This 0 is applied as an input, one of the input to this OR gate. 0. 0 or 1, I will get 0, 0 bar I will get 1, so I will get 1. So what I got, Q is 1, Q bar is 0. So is written here Q is 1, Q bar is 0. So Q is 1 means it is in the set state. It is in the set state. Okay. So next, the last row. So when I am having 1, 1, okay, S is 1, R is 1. Assuming Q is 0, Q bar is 1. So this 0 will come here. 1, 0 or 1 I will get 1. Here I will get 0. So this one I will get 0. So this 0 I have applied here. 1 or 0 I will get 1. 1 bar I am getting 0. This one I will get 0. See students, both the sides I am getting 0. But I have already told you that Q and Q bar are complement to each other. See whether they are complementing each other. No, they are violating this, isn't it? They are violating the complement rule. So if Q is 0, Q bar should be 1. But for S is 1, R is 1, both are 0. It is known as unpredictable behavior, which results in the input return to 0 simultaneously as it is violating the complement rule. Hence the last row 1 1, when S is 1, R is 1, both the outputs are returning to 0 simultaneously, and hence it is known as unpredictable behavior. It is violating the complement rule. Q and QR should be complement to each other. So this is how the SR latch works.